I hear a bit of an
Sure.
echo from your speakers, I think.
Is it better now?
Let's see. Yeah, that's better.
Okay. Okay. So welcome to the webinar, Ian. I'm really excited to talk to you about open source routing engine. This is a new topic for me as well. I have not worked a lot with the open source routing. And for the viewers, a little bit about Ian. He's doing amazing work with Stadia Maps. I see this name popping up almost everywhere now. Like across every conference, someone somehow is working around with Stadia Maps. So, Ian, do you want to start with explaining what do you do on with Stadia Maps and what's it's about? Yeah.
Yeah, yeah, I guess I'll just jump right in. First, I'll just do a quick couple words about myself, and then can jump into Stadium apps. Yeah, I'm originally from the U.S. Now live in South Korea. Krishna and I met at Phosphor-G Asia a couple of months ago in November. That was really awesome. Getting to hang out with you for like 3 days
Yeah.
there was one of the highlights. Actually, we had so many good wide-ranging conversations and good food together. That was a lot of fun. I got into open source software back in I think it was around 2002. I'm having trouble because I didn't have like Facebook and all that stuff didn't exist back then, so no records to go off of. But I think it was around 2002. Got into the FreeBSD project, which is one of the free open source Unix derivatives. Um, and then I kind of accidentally got into the whole geospatial industry in 2017, which is when we started Stadium Apps. So yeah, at the time I was doing a mix of mobile and backend development as a consultant, and one of my clients was going to get a bill from Google that was going from $0 to $700 a month. This wasn't a part of their
Wow.
core business or anything, and yeah, it was crazy. So we were just talking with the CEO, and we were like, okay, well, he's like, I'm not going to pay this. Like, there's either going to be some other service or whatnot. So we looked around, and we didn't find anything that fit the bill for them. So we decided, let's start our own thing. How hard can it be? Famous last words. Turns out it's actually it's actually pretty hard. But yeah,
I can
but since
imagine.
then we started with just the base maps, and then now we've expanded to we started routing pretty early on. More recently, geocoding and yeah, all kinds of other things, and have just kind of grown from there. We're a small team, just three of us, and yeah.
Great, great. That's amazing. So I believe you'll be talking more about how you integrated like routing engine into the
Yeah.
Stadia Maps, right? Yeah,
Yep.
perfect. So I think so. If anyone is interested into reaching out to Ian, we will be posting his email and you can always reach out to him on Telegram channel of GeoBharat. So yeah, over to you. I'll be off the screen now. If you need me, just give me
Yeah.
a shout out. I'll immediately join. All right, over to you,
Awesome.
man.
Thanks. And by the way, everyone, please feel free to leave a comment in the chat if you want to interrupt. I'm a pretty spontaneous person and like to keep things interactive. So I see Pawan already said the routing engine is cool. Thanks for your comments. Keep those coming as we go through things. So the kind of way I'm going to run this talk today is we'll start off talking about the landscape of free open source routing. We'll go into the basics of Valhalla itself. Then we'll do a little digression into some of the internals of how routing systems work. And that'll give us a foundation to understand what we talk about in the advanced routing section. And then I'll try and leave a bit of time at the end. So you guys can decide. You can ask me some questions or go off on more details into anything. Starting things off, though, if you're in the chat, I would love to find out a bit more about the audience. Are you a developer, or are you a GIS professional, or a bit of both? If you can just leave a quick comment, that would be awesome, because then that will let me tailor the language that I use a little bit better.
I think most of the viewers will watch it, after
Live
after.
or archive?
Yeah.
Yeah. Yeah.
But
Okay.
most of them are from professional background. We are
Okay.
trying to. So yeah, I mean the whole idea is that we are trying to allow GIS professionals to get a little bit of understanding of development. So yeah, most of
Yeah.
the people are from GIS professional background. Yeah.
Awesome. Cool. Okay. Thanks, Krishna. Awesome. So, why free open source routing? You've got Google, you've got all the Mapbox, you've got all the big names that everyone knows. So why are we even here today talking about something else? Um, One of the things that I really like about the free open source space is you get so much flexibility. Most of the proprietary solutions are focused on things like cars and trucks, and this obviously makes sense in the market today. If you look at where all the money is going, these logistics operations, fleet operators, ride sharing, it's a huge market. And if you're a massive company with multi-billion-dollar market cap, then that's something you got to focus on. But this leaves a lot of use cases that are underserved, which I think are really interesting if you're a GIS professional. Um, just a couple of random examples, like in South Korea, it's usually really safe for a woman to walk alone at night. But in a lot of the world, then there's a very real use case for safer pedestrian routing that prefers lit areas at night. Another example would be avoiding stairs. So there's all kinds of things. Future of mobility is quite possibly going to look very different from just cars. And free and open source routing engines are at the front of being able to provide this kind of flexibility. We've actually done a little bit of work around this space ourselves, working with government organizations, and being able to integrate directly with OpenStreetMap is a real value add for both sides, because the government agency doesn't need to um, give you an export of a shape file or something on a periodic basis, and then you integrate it into your system. By using OpenStreetMap directly as the medium of data interchange, then it enables everyone to have a really cost-effective solution for getting updates into their routing engine really cheap. And then, of course, you have the freedom to modify the code directly, bring your own data, run on premises, and so on. And I think almost everyone here is going to know a bit about the benefits of the network effective open source software. So a bit about the landscape. There's a number of fantastic free and open source routing engines available. Some of them I'm pretty sure have more than a decade of development, so they've been around for a while. Like OSRM, I think, is one of the oldest ones. It's been a staple in the OpenStreetMap community. Grasshopper, another absolutely great product, written in Java. The developers are they run a commercial business like us, but they have the core product is open source. And then there's Valhalla, which is the one that I'm going to be talking about today, because that's the one that I'm the most familiar with. So we selected that for our work at Stadium Apps for a few reasons. First, it's one of the most flexible routing engines available today. I'm not sure if it's the most flexible, but it's got to be pretty close to the top there. So, for example, Google, I think, has 3 or 4 different ways that you can get directions. You can say I'm walking, or I'm cycling, or I'm driving, and I guess public transport in some areas. Mapbox and most other proprietary solutions are similar, but Valhalla has over a dozen different ways of saying, like, I want to I want to walk, I want to use a motor scooter, I want to use a bike sharing scheme. There's all kinds of options. Um, and each of these has a dozen or more options associated with it. For example, you can specify, how heavy is your truck? Are you transporting hazardous materials? Do you want to avoid busy roads? And Valhalla lets you do all of this flexibly at request time without having to go and write some C++ or something like that. So as a professional in the industry, this is extremely useful, and you don't have to be a programmer in order to get most of the power out of it. It's also pretty fast. It's written in C++ and makes really effective use of things like memory and disks if you can configure it correctly. So this is useful for doing like massive time distance matrix calculations. And finally, it's got a pretty proven track record in the industry. Mapbox actually uses this to power their routing APIs. Tesla also runs a fork of the core code base, so that's powering the routing in all of the Tesla vehicles. Unfortunately, neither of these companies contributes very much back, and they don't expose much of the raw power to their users, but the code's open source, and so you can either run it yourself, or you can use a hosted solution like ours is Stadium Apps, which is exposing the full power of the API for you. So enough talking, let's get to some doing. I'm gonna try and do a bunch of live demos throughout this talk. Hopefully nothing goes wrong. So let's switch over to the other desktop here, and yeah, cool. Let's dive into the demos. So we're gonna look at everything both in QGIS and the API workflows. So whether you're a software developer primarily or using the desktop GIS software, we'll have something for you here. We'll start with QGIS because it's a bit more visual and intuitive, and then we'll look at the API when we get to some of the more really advanced features. So start off, you have your basic QGIS set up with a base map. You can use whatever you want. I'm today using the terrain map from Stamen Design. I really like this for visualizing routes because it also shows the topographical features, which are useful for like cycle routing, and you can see like paths for pedestrian and golf cart use in this particular community. We're going to use a plugin. So there's a Valhalla plugin for QGIS. I think if you just go to the search QGIS Valhalla, you can find it on the plugins.qgis.org. And this is developed by one of the maintainers of Valhalla, actually. So yeah, really good plugin. So we can click it with this little logo here in the top bar, and then sorry, stuff pops up on the wrong screen, and we get a whole bunch of options. So right at the top, the first one is provider. Sorry, QGIS is popping the menus up on the wrong screen, so I can't show you all the options, but there's two options by default. There's one which is for FOSS-GIS, which is a German nonprofit devoted to free open source geospatial software. They run a public server, so you can actually use this for free with like, there's some limits, like only one request per second and stuff like that, but it works for just getting started, so you don't need to run a server yourself. You can also use localhost, or you can add your own server, and you could like connect to our APIs, for example. I'm running on localhost because I have something running, so it'll be really fast and don't have to hit the internet. Next, we have method. This is unfortunately the options aren't showing up, but we can do basic routing, which is what we'll mostly focus on. But you can also do things like isochrones, which are super useful for urban mobility analysis. An isochrone is a visualization that shows areas of equal travel time. So from this point in the city, how far can you walk within 15 minutes, or how far can you cycle within 10 minutes? And then this is a really powerful tool for exploring urban mobility for city planners and things like that. And we can take a look at that a little bit later. You can also get specific attributes of the road at a particular point, so you can see how the routing engine is looking at things. And this is really useful when you get into the advanced routing. You can go with a couple of different vehicle types. The plugin exposes automobile, truck, bicycle, and pedestrian. And then you can select this mode, which is either fastest or shortest. Fastest is the one that we'll look at primarily. Shortest is just the actual shortest distance, but that usually isn't what you want in most cases, but it's there in case you really do want just the pure shortest path. So how do we actually get a route? So we can click this little plus button, and then we can just click areas on the map in QGIS. So let's, I'm just gonna pick something random. let's go from this little subdivision here over to this one. So I just click 2 points on the map, and then I bring up the plugin window again, and we see that we have 2 points now. We can click the apply button, and then it will get us a route, which is not very easily visible. So let me change the symbology a little bit. Let's make that like 5 millimeters or something so it shows up. There we go. Okay, so we can see just open up the Valhalla dialog, click a couple of points, and then we can get a route. And you can do this without having to run your own server or anything. We can also look at some of these other options, like the, let's go to the, sorry, wrong one. Let's go to the locate option. And I'm going to select a different set of points here. I'm going to say, what is like this road here? So you can click a point, go back to Valhalla, click apply, and in the locate mode, what we get is this, it just shows the raw JSON response from the API. So this is a little bit more developer-y, but I'll walk through the information because it's actually quite approachable. So we get nodes are basically like points like intersections, and edges are road segments. So edges are the thing that we're gonna look at here. If you have live traffic information available, you can enter a you can see live speed information that's returned here. So if you're subscribed to like TomTom or Here Data, you can integrate this with your Valhalla server, and you can get live speed information back from it. You get linear referencing, which is a standard specification for describing points along the Earth like this. You can get information like the speed limit that is tagged. So this data is coming from OpenStreetMap, and this area is quite well tagged. So we can see that the speed limit is 89 kilometers per hour. We can see the name of the road. It's called Joel Cohen Parkway, also Georgia Route number 74. You can see if it's part of a bike network. I skipped over, you can see the way ID. I believe that is cross-referenceable directly into OpenStreetMap. Here's where we go off script and find out if we're right or not. OpenStreetMap.org/way/this. Yes, awesome. Cool. So everything lined up. No one edited the data in a way that that broke things. Yeah, that's cool. So you can go directly from routing information and cross-reference it with OpenStreetMap. So if you detect a problem, for example, all the data is right here, so you can cross-reference it in OpenStreetMap. You get information about what the surface type is. This is useful when we get into the more advanced types of routing. Because, for example, a bicycle, like a road bicycle, will want to prefer paved surfaces, but a mountain bike can go on a dirt track. You can see whether it's accessible to a number of different costing models. So you can see whether this is accessible by taxi. Yes. Accessible by moped, yes, but it is not notably accessible via golf cart. I see we have a question in the chat. Do you need to know PyQGIS or Postgres for using the routing or Isochrone plugin? The answer is no. I have done no additional setup for this except clicking install. I didn't have to write any code in order to do that. I believe it probably requires Python to be installed in the QGIS environment, but you don't have to write any code or do any special configuration yourself. I just downloaded QGIS on my Mac and have nothing special as far as configuration goes.
Hey, hi
Yeah.
Ian. There is a question that do you need to know PyQGIS or Postgres for using this routing or Isochrone plugin?
Yeah, as far as I know, no. I just clicked install plugin in a default QGIS install.
Mhm.
I believe Python probably has to be installed, but I didn't have to do any special setup on my Mac.
Okay, so you don't need Postgres or PyQGIS to get it working.
You do not need Postgres. For sure, you do not need Postgres. And you can use a public server as well. Like I'm running against localhost, but I could also switch this to run against the public FOSS-GIS server and click apply, and I get basically the same thing back. The public server does not have golf cart access information because that is not yet upstream. That's something that we're working on upstreaming right now. But
Okay.
yeah, otherwise, yeah. Okay, so back to any other interesting attributes here that we should highlight. Elevation data as well. You can get information about the grade. Yeah, I think that's most of the interesting information that comes in here. Yeah, whether there's a traffic signal, lane count. Yeah, there's a whole bunch of information here. Most of this is useful for navigation applications, which is something I'd be happy to talk about at the end. But if you're just doing like GIS analysis, then not all of this is necessary. But there's a whole lot there, and you can get all these attributes back. Cool. What do we want to talk about next? I think that's most of it for the basics for QGIS. Let's pop over to this other tab here and also look at API workflow. So if you're a software developer, we have SDKs available as well as an open API spec, so you could generate your own. In fact, you could use the open API spec with minimal modification. Like we have some of the paths are slightly different, like you would drop this V1, but all the data models are there, and you could use this to talk to any Valhalla server. The responses are the request and the response are just JSON, so pretty simple structure like this. If you're using QGIS, actually, you can also see the parameters here for the requests, and you could basically like copy those over. So if you wanted to like try getting a route and then do it in code and do some analysis on it, you can copy the request here. So this is just the JSON request body. We also have an interactive API Explorer that you can use to just interact with the server directly. You can, of course, also use Postman against the public FOSS-GIS instance, but this is a quick way to get going in your web browser. And I've preloaded a request here. I click execute, and then you get back the JSON. So this is like what drew this line here. So you have all the directions of what to do, like turn right here and stay on this road for 200 feet and so on. And then you have a Google encoded polyline. So you can use a polyline decoder and like JavaScript or Python. If you just do a Google search for polyline library, you'll find find options in basically every programming language. Just a compact way to represent all of the points that are visited. If you want to get a visual on this and you're a developer and you're going through the API workflow, you don't actually need to use QGIS. We actually published a open source tool on GitHub Pages, and you can copy the response from the API here, and you can go and paste it over here. And this is a different route. I pre-programmed this in, whereas I clicked the to live over here, so it's a different route. So don't worry about that. But what you can do now is you can hover your mouse over the individual sections of the route. We call these maneuvers, and you can see the details about that. This is extremely useful for like debugging and kind of seeing why is the router taking me this way. You can see attributes like, of course, the street names and the turn instructions, but you can also see things like this is how long it thinks that it will take to traverse this particular section of road. So it thinks that it will take 113 seconds, 104, or sorry, 134 seconds. I can't read to traverse this particular section, and and it's a little over a mile long. It's with a car and so on. So yeah, useful tool. It's called Ragnarok in the theme of the Norse mythology. That the Valhalla team came up, and this is available on GitHub. Um, at this point, does anyone have any questions so far? If you want to, if I glossed over anything or you wanted to go deeper into something, then please add a message in the chat. Otherwise, we can go on to a few more advanced topics.
Yeah, I think we are good to go.
Awesome. Cool. So we'll talk about next how computers see roads. How is the isochrone generated? That's a really good question. Um, could you elaborate a little bit more on the detail? Do you want to just show an example? I'll just show an example real quick while I'm waiting for a response on that. Go to isochrone mode, and I'm just gonna. Uh-oh. Yeah. Okay. Coverage area of an amenity. So what you would do is you would find the okay, so you want to find a coverage of a particular type of amenity, and you want to see how many are available within the isochrone area. Isochrones minutes 10. Okay, cool. Uh, is that 10 minutes? That doesn't. Oh, I guess maybe it is. Let me try and get a slightly better example, and we'll work through your example question and how we could answer that. Okay, so first one, you wanted to you want to have a particular type of amenities. So the way that I would do that is by using there's a great QGIS plugin called Quick OSM. I believe if you just search Quick OSM, yes, then you will find it in the QGIS plugins repository. So let's search for amenity. Does it have autocomplete? It doesn't. I think amenity shop is a valid one. Let's try this. A named area is required when the query is in. Oh, um, let's try canvas extent. Missing some values. Okay, yes, all OSM objects with key amenity equals shop are going to be downloaded. Okay, cool. Run query. Successful but no result. Okay. My apologies. This is fun live. Let's find all the bars. Okay, cool. Amenity bar. Successful query. Did that? Successful query one layer has been loaded. I think that's it. Yeah. Okay, cool. Okay, let's make these a little bit bigger. Okay, cool. So we can use the Quick OSM plugin to quickly get all of a particular type of amenity, and then we can select a starting point for the isochrone, like this. And then under the method configuration isochrones minutes, let's just do like a 5-minute one to actually let's since this is not a very useful map since I was too zoomed in, I'm going to rerun the quick OSM query, get a bit more data. Amenity bar in canvas extent. So canvas extent is going to be the area that's visible on the screen. Run the query. Okay, this area apparently doesn't have very many bars, so we'll work with it. Make that a little bit bigger again. Awesome. Okay, back to the Isochrone configuration. Set minutes to 5. Yeah, we want polygon and okay, yeah. Okay, apply. So that's all the 5-minute driving distance from that area. It's not very readable right now, so we will change the opacity, maybe a little bit more, and then yeah, you can generate maps like this to see. So the way that it works internally is it will try expanding the graph out toward it'll just try expanding the graph out as far as it can, and based on travel times. So you can see you get these like little shots out, which you'll see again in another visualization that I'm going to show later. And this is because you can travel very fast along this this motorway, whereas in the urban center you can't. So it ends up being like this kind of narrow range, and you can see like even like these particular areas are separated. There's no roads connecting them, and there's a stream in the middle. So so this area here is not accessible. And then someone who knows a bit more about QGIS than me, I'm more of a programmer than a GIS professional. Someone who knows a bit more about QGIS than me would be able to do a query and say, okay, give me the count of features in this particular layer, the bars layer in this case, that are within this this isochrone. Does that answer your question? Hopefully, yes. I will proceed from now on talking. Okay, cool. Thanks. I'll talk about how computers see roads, and we can and we'll actually see a cool example that will kind of explain visually how isochrones are generated. So computers look at roads in this structure called a graph. Um, a graph contains nodes and edges. In GIS speak, then these would be like points, and then line strings or some similar feature like that. Um, and if you're familiar with OpenStreetMap, then you may have seen some similar terms. Nodes and ways are in the OpenStreetMap data model. Um, and the way that you model a road in OpenStreetMap is by having a bunch of nodes that are connected by a way. Similarly, if you're modeling a road in QGIS, you would have a line string, and you could even join multiple line strings together to make one road, as we would call it as humans, that has different attributes on each section. So for example, along the course of a major road, the speed limit may change multiple times, or the number of lanes may change. And these are represented in the computer in these things called edges. So edges, road segments, from now on I'll use the term edge since we're talking a little bit at the deeper technical level. They have a bunch of attributes associated with them. Length is the most obvious one. The class of the road is another important one. So for example, is it a major highway, or is it just a residential road? You can have information about the surface of the road, what its speed limit is, access restrictions, which types of vehicles are allowed to access it, and so on. All of this information gets distilled down into a single number inside the routing engine that we call a cost. And this number is used by the routing engine to say, okay, this is a really expensive road. I don't want to traverse over this because it has some undesirable attributes. Like, say, a dirt road is probably not going to be very desirable because it's a low surface quality. Your speed is going to have to be reduced, and all of this information gets distilled down into a number. And you can probably imagine that the number is going to be different for different types of routing. So a golf cart is going to have a very different idea of what a good road is compared to a pedestrian or a cyclist. A cyclist is probably going to want to avoid major roads, as will most golf cart drivers. But cars, for example, would want to seek them out because they're going to be faster. So all of this, all of these rules get get distilled down into basically a set of like math equations, and this is what we would call, as like normal users, like in Google Maps, we would call this like a routing profile or a routing mode. So when you open up Google or Apple Maps on your phone, then you probably get 3 or 4 options. Like you probably have pedestrian, bicycle, car, and then maybe a public transit. Valhalla, as I said at the beginning, has over a dozen of these, including things like bike sharing and golf carts, which is something that we're working on open sourcing. So this is like a simplified diagram of how the computer looks at things. So you have these nodes A, B, C, D, E, and F, and these can be like intersections in a road network, or a public transit network for that matter. And each of the edges has a cost associated with it and a direction. And so then, as a human, we have these decades worth of neural pathways built up. We can see pretty quickly that the best way to get from A to E is going through C, because if we went through B, then it would be much more expensive. And computers have these processes called algorithms that they can use to determine what the optimal path is. I'm not going to go into the details of that, so don't worry. You don't need to understand the graph theory or the code or anything behind it. But there is a pretty cool visualization that I can show you, and this is the one I was talking about a second ago. So this is going to show how a route search actually happens. And this is also similar to how isochrones would work, except that instead of having a goal that it's trying to get to from one point to the other, there is no goal. So it's just expand, and you stop when you hit the time boundary. So without further ado, cue the YouTube video. And so you can see we're trying to go from the northeast of Chicago down to the southwest, and the search expands in the direction of the points. And then you can see, like I was saying, this like suddenly you get these like really quick offshoots because the highway is a much more efficient route for the car. And you can see a similar kind of visualization here playing out in Rome. And there we have it. Boom. Cool. Okay. Now on to okay. So we've got that was a bit of background. But understanding how the computer views things and this concept of edges and costs associated with each edge is really useful for doing more advanced kinds of route influencing. So Valhalla gives us over a dozen tunables that we can play with. So for like motor vehicle costing, we can specify attributes about the vehicle, like its length, its weight, whether it's carrying hazardous materials, and whether it's eligible to use HOV lanes. So like in some countries, you're allowed to use like these designated high occupancy vehicle or bus lanes. You can specify all of these attributes directly to the router. Um, we can we can prefer lit areas for pedestrian routing. I talked about that earlier. we can avoid hills or say that we don't care. This is really useful for cyclists. And we can even say, I don't want to go to this particular area, which I'll show a live demo of in a minute. So those are the things that you can do with it, but it boils down to there are a bunch of different ways that you can influence the routing in Valhalla. The costing model at the top level is the obvious one, and then there's a whole bunch of things that we'll drill down into. I'm going to cover a lot of material here, but don't worry, you don't need to like write down copious notes or anything, because I've written all of this up in a guide. And in fact, I'm actually just going to switch over to the guide right now. This is applicable to any Valhalla instance and not just ours. So we have, I'll start at the top. Costing models are the most, let me increase the screen size a bit here. So costing models are the first thing. Obviously, a car, automobile is going to be very different from like a bicycle. So select the right costing model, you get different routes. No surprise there. You can influence which direction you want to start at the beginning of a route by setting the heading. This is really useful for rerouting. You can avoid areas. You can set attributes on the vehicle, which we just talked about: length, weight, axle load, hazmat, and HOV. Yeah, you can also set the top speed of the vehicle. This is also useful. If you are driving with a vehicle that you know has a limited max speed, like a truck or a motor scooter, you can set that, and then you'll get better times of arrival back. Then the meat of things. This is where things get a little bit more complicated. There's a lot of terminology, which is why we wrote this up in a guide. So costs and penalties are the most common ways to influence the characteristics of a route. A cost is a number of seconds that is added to the estimated time for a route. So when you encounter a gate, so like a private access community, that has a cost associated with it, and that gets added to the time of the route. Similarly, if you need to board a ferry with your car, then there's a ferry boarding time that's added as a cost. If you want to rent or return a bicycle from a bike share station, that also has a cost associated with it. Penalties are very similar, and it's a subtle difference because they're also measured in seconds, and they also affect the route that's generated. But these do not actually affect the trip duration directly. This is only used internally for the purposes of saying which route is most optimal. So penalties are the thing that you should probably use if you want to avoid a particular type of feature rather than costs. Costs are just for fine tuning. Like, you know that that a particular country border crossing is a really fast one or a really slow one. That's different from the defaults. You can change that as a cost, but probably if you want to say, I really want to avoid crossing an international border, or I really want to avoid gated communities, or I really want to avoid changing roads, that's a very useful one. If you would prefer to just stay on the existing road, even if it's a little bit less efficient, then you can use penalties for that. And these are great because they don't actually influence the travel time. You can set the value to something really crazy high. Like if you're building a public transport routing app, for example, you can have two modes. You can have the fastest mode, which gets you across town as fast as possible, but it may involve a couple of transfers. And then you can have like a comfortable routing mode. And the way that you would do that is by setting this maneuver penalty to a really high value. So you can say it takes 10 minutes to do a transfer, even if it doesn't. You can add this additional penalty on top of it, and the travel time calculation will still be correct, but you get the modified behavior that you desired, which was to minimize the transfers. We also have these things called factors. These are a little bit more complicated. They multiply the cost of a particular edge. So like in this QGIS example, this segment here is going to be an edge. So if I want to multiply the cost of a particular class of road, which is what these are used for, say I want to multiply the factor for service roads, which are like small roads in between buildings, more or less, highway access roads, things like that. If you really want to avoid those, you can multiply that by this factor. Um, the reason why they're a bit trickier is because it's dependent on the length of the road that's traveled, and so these can be a little bit they can have confusing behaviors sometimes. So normally you want to use penalties, but factors are another option that you have at your disposal. And then finally, willingness to use. These are all a little bit different, but in general, you have the value 0 indicating that you want to avoid something, and then 1 is either you prefer something or you're indifferent to it. So for example, use highways, that's more on the side of like 1 is I would prefer to use a highway. So most motor vehicles, most of them, not all, most motor vehicles are going to have use highways of some higher value like 1. But if you want to avoid highways, then you can set use highways to 0. This doesn't completely block out highways, by the way, or any of the other factors. It just indicates a strong preference one way or the other. So if there's no way to get from one point to the other without using highways, then it will still take a highway. And there's a whole bunch of options here. Highways are the most common one, I think. Toll roads, also really useful. There's a couple of bicycle-specific ones, like use roads. So this indicates the preference or willingness to use a road alongside other vehicles. If use roads is set to 0, then it will strongly prefer designated cycleways. Whereas if it's set to 1, then the rider is basically indicating that they don't care. So you can do really, really flexible routing with this. You can use lit for pedestrian routing. Motorcycle riding, you can set use trails to 1 if you have an off-road motorcycle and are really looking to go on the back trails. Yeah, there's so many options here, and I could probably talk about specific use cases and details for an hour, but I would just say go to our guide, getting the most out of routing with Valhalla, and you can get more there. So a couple quick more live demos. Let's try doing this avoid areas feature. So I'm going to zoom in here. I'm gonna generate a, what do I do? I need to click the points again because I went on a detour. So there's our start and our endpoint. Go back to the Valhalla panel. Yes, I need to add a area that we're going to avoid. So what I'm gonna do is I'm gonna zoom in here on the map, and I'm gonna say we don't want to go here, and then it's gonna route us around that. So the way I'm gonna do that is I need to create a new layer in QGIS, new temp scratch layer. We're gonna do this with points. And of course, if you're a professional, then you probably already have some data set that you're pulling in some other way with like Postgres or something. But I'm just gonna click stuff manually here for the demonstration. I don't think we need any field names. It's just gonna be yeah, avoid points. We'll call this layer. Then I'm in edit mode. I need to add a point feature. I'm going to click right here and make it so that we can actually see this better. Let's pick a color with contrast. So let's go for like blue or something. Cool. We'll go for blue, and then we'll make that like 8 millimeters so it really stands out. Okay, cool. So that's the point that we want to avoid. we go back to Valhalla, and we can now see how to configure this. So we want to go back to route mode, auto fastest, and we can collapse this. Whoops. Yes, we want to avoid geometries, and we will select. Oh, oh, this is cool. I never thought about this. Um, uh, oh yeah, this is cool. We could actually like this is a dumb example, but we could actually avoid the bars that we just pulled in from OpenStreetMap. So that's a cool use case I hadn't thought of actually. You can use the Quick OSM plugin to pull in information either as points or as polygons. It supports both, and then you can use that for your query. That's cool. So, anyways, yeah, the avoid bars won't be very useful though because there were only two of them and they weren't on the route. So, we're gonna select this avoid points layer, and what this will do is it'll route us around. It'll try to match the nearest edge. So it'll be like probably this segment of road here is one edge because there's so many intersections along here. So it'll match the edge based on the snapping the point to the edge graph. If you do polygons, then it will you can specify multi polygons as well. So like if I drew a giant box here, then it would exclude every edge that touches that box. Yes, 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 exactly. I see your question in the chat. Can we avoid
Yeah,
certain
can we
polygon
avoid
areas too?
yeah.
Yeah, that's exactly. Yeah, it's so cool. Yeah, you can avoid polygons as well. I don't have like a good data source set up to do that, so we'll just do the points for now. So apply, close. Where is route auto? This is not very visible. There we go. And let's make this one a different color. Make this one green. Neon green. Okay, cool. There we go. So our so now the second route that we got, it's got the same start and destination, but it avoided this particular area here, and you can see it like just as like a human with your eye, you can see it went around here, and none of these are acceptable because it's a one-way road going the other direction to the west in this case. So it goes to the nearest available intersection and then onto the destination. So um, yeah, you can do a lot of cool stuff with that. You could probably do a quick OSM and grab a polygon um, for like a specific golf course or a subdivision or something like that too. Yeah, so there's a whole lot of stuff you can do with that. What else can we do? We can also, let's pop up here. So the QGIS plugin doesn't have 100% of the options that are available via the API, but it has a lot of them. So let's go into, actually, I don't think I ever looked at a method configuration is basically just for isochrones. Oh, and the locate as well. Oh yeah, you can set the tolerance, for example, like radius 2 meters for when you're getting raw information. That was something that we looked at earlier. Let's go to the costing options though, because this is where most of the stuff goes. So auto, um, you can see a lot of the stuff that we talked about earlier, like the maneuver penalties, for example. I want to stay on the same road for as long as possible. I don't know if I haven't really set up this example very well to take advantage of the flexibility it offers, but like because I don't think there's any like toll booths or anything in the area. What if I wonder if let me zoom out a little bit and see if we can come up with a clever route that avoids some particular feature this way. Might be able to avoid highways. Let's try that and see. Um, so pull up Valhalla here. Use highways. Is that right? 0? I guess this sets these all to 0 when you check the box. Let's see if that does anything. I don't think it. Yeah, I don't think it came up with any different route. Yeah, it's just this. It's the exact same route. It's this line in the middle. Yeah, I'm not thinking of a great example to show off the top of my head here. But yeah, you've got a ton of options. We looked at isochrones. So last thing I wanted to show is this this golf cart routing profile that we have, and showing you how you can do that with the API. So we can set costing to golf cart, hit execute, and we can actually use this other tool that we built to kind of toggle back and forth and see the difference between two routes. So when I go back and forth, you can see the start and the end point are the same, but the path in between is completely different. So the car route is sticking to the major roads, and then and then the golf cart is actually able to cut through on all these minor residential roads, and then these multi-use paths that are designated specifically for golf carts. So yeah, that's all the stuff that I had to talk about, like in my notes. If there are any questions, I would be happy to take them. What else could we use to wrap things up here? Yeah, I guess I'll go to the slide with some other resources to talk about. So
Do you
if you
want
want to,
to give
yeah,
a brief about like how exactly, like what all features you have integrated from Valhalla into the Stadium apps? Like, can you just give us an idea? And what are the bottlenecks like you have run across?
ooh, the second question is really interesting. So the features that we've integrated from Valhalla, well, basically all of them. We exposed the full Valhalla API. However, all the features is a little bit of a tricky question. For example, Valhalla does support live traffic, but that isn't something that we offer in our public APIs. It's a complicated question of licensing, so we can do that for like an on-premises enterprise deployment, and because you need a specific contract, and it's based on the number of users and all that from like TomTom or here or a similar vendor. So we don't offer that. We also do not offer public transport routing in our live stuff right now, just because we haven't quite figured out the right mix of like data source and the quality and stuff. We want to offer something that's pretty good. Yeah, so that's kind of the status on things. You asked about bottleneck. RAM is probably the bottleneck in a well-tuned deployment. You do need, actually, yeah, let's talk about that a little bit on the technical side. So when you're okay, the process for generating like a Valhalla deployment, all the data for it is you have the data from OpenStreetMap. You need to process that a little bit
Mm-hmm.
first to get out the administrative areas, because like for example, we know that in most countries in the world drive on well, you're driving on the right side of the road, and the driver is sitting on the left hand side. And then in many other parts of the world, like in UK, Japan, New Zealand,
Yeah.
maybe you guys as well, in India.
Yes.
Yeah,
Yes.
so
We
it's
follow.
flipped. So so yeah, so anyways, all that information has to be taken into account, because then it's whether the right turn is easier or the left turn is easier, and so on. So that's a massive processing job. The whole process. Oh, and then the third component is time zone information. That's useful in some cases. So the process to do all that takes, you can do it in less than a day, like less than 24 hours on a well-tuned configuration, but you need a lot of RAM, and you need pretty fast disks will help. Or you can use there's some other tricks you can do too. Like if you're on slow disks, you can use a file system like ZFS that has compression built in. So yeah, those are kind of the bottlenecks as far as the data building side, and that's at the planet scale. If you want to just run for your local city or state, then you can do that on a reasonably spec laptop.
Got it. And we can also like feed our own data to it. I mean,
Yeah,
apart
yeah,
from,
yeah.
so
Good
that
question.
yeah, yeah, because like this might be a use case for a lot of people, is that like I was working with one of the clients who had like a really big area for mining,
Hmm.
and they had everything, like they had their own like stops and the like point data of all the stops, line data of all the roads that are there,
Yep.
because it's a barren land. They created everything from
Yeah. Yeah.
on its own. So like they were
Yeah.
really interested into like creating a routing system for their
Yeah.
trucks, which
Yeah.
probably can also work in offline. So yeah, I mean, like, can
Yeah.
I then put Valhalla in that?
Yes. So there's two questions. One is like the whole like offline thing, and then the other is bringing in your own data. So bringing in your own data, I'll put a actually let me just find that right now. There's a really great thread on Mastodon from a guy who talks exactly what you need to do with this. So Valhalla, everything is using OpenStreetMap data as its base, but you can still bring in your own data using JAWSM, the Java OpenStreetMap editor.
Oh, yeah.
You can actually take your OSM extract and then edit it in JAWSM to add your own proprietary data. And then he was doing this for urban mobility exploration. Let me grab the link here, and then I think I can paste it in the chat.
Yeah.
Yeah, this thread is great. So he talks about how to do this to like add a new road or add crossings or things like that, and then you can build your own Valhalla instance locally off of that. Let me copy the link to the post, and I think if I need to connect my YouTube account. I'll send you the
Yeah, you
link,
can send
Krishna,
me.
and then yeah,
You can
yeah,
send, or you
yeah,
can send it on the Telegram channel. Yeah,
yeah.
perfect.
I just sent it
So
to you directly.
paste it in the chat.
Yeah.
Great. Uh, and second question was for offline. So do you have any comment on
Yes.
that?
Yeah. So if you want to just run on your own server, then yeah, of course we can assist you with getting everything set up on your own hardware. If you're talking about like offline on like a mobile device,
Mhm.
then yeah, that's actually an area of active development for us right now. So I'm involved in a bunch of different projects in the space. One of them is building a mobile navigation SDK that's properly free and open source. That's one of the links here. It's called Ferrostar. It has direct integrations with Valhalla from day one. It's in, I would say, it's late alpha stage right now. We think that it'll be a solid beta within a month. And there's a couple of other people from the OpenStreetMap community that are working on that to make that happen. Along with that, then one of the most common requests is, of course, okay, well, I'm in a place with bad internet connection. How do I download the tiles
Mhm.
directly to my phone
Correct.
and then do the offline routing? So that's
Yeah.
what this Rallista. Rallista is the company behind an app called Rallista, who's collaborating with us on the development of Ferrostar, the navigation framework. So we've been collaborating with him on a Valhalla mobile SDK, which is the Valhalla is written in C++, so it can run anywhere in
Mhm.
theory. It's just a matter of making it nice.
Correct.
So
Correct.
we're working on the making it nice part. That's also like a solid alpha. It's usable, but yeah, definitely developers in the community. We would welcome further collaboration on that.
Awesome. I think there is another question from Pawan.
Yeah.
It's like advanced features like OD, cost metrics, and fleet management. Like, can that be done as well?
Yes. We don't do well, we don't handle fleet management for you directly, but we do offer time distance matrix. So that's yeah. Well, okay. We offer two things. First, we offer optimized routing, which is for a single vehicle. But then you're probably asking about um, the more like rich vehicle routing problem kind of stuff, which is in the time distance matrix. So you can use our time distance matrix as an input to other like solvers and optimizers. Like Optiplanner is probably the most popular open source one written in Java. Um, there's also one C++ one called Vroom, which is directly that has direct Valhalla integration already. So that would be one to check out. And of course, you could also integrate it with OptiPlanner, with it just be a little bit more code.
Perfect. Yeah, I think that's all that I have to ask. It
Awesome.
was really amazing 1 hour. I think that this opens up a lot of things, a lot of possibilities for me as well. For on a
Yeah.
personal level, I would definitely like to see how exactly I can use Wahala in the current projects, or maybe come up with a use case, because like routing is obviously one of the things that's expensive. um, and if you just need routing but that's not your main business, it's very hard to justify that cost, as
Yeah.
in your business. So probably always people are looking for alternatives for that, like, so a lot of transportation companies here in India, they do have like fixed set of routes, or
Yep.
generally, like, when you are doing
Yeah.
trucks, you are not
Yeah.
going to take small routes which are like under construction right now. So for trucks or for like heavy vehicles, these are usually planned routes which are big and which are there for like forever. So
Yeah.
like using something like this instead of going with a proprietary or enterprise solution can help them to save a lot of money, is what I think.
Yes.
And yeah, I'll definitely explore more about it. For the viewers, Ian has already given his email. You can connect with him on Telegram channel as well. And
Yes.
yeah, thanks a lot, Ian, for doing this. And one other thing that I would like to talk about, Ian, is that when we were talking about doing some things on GeoBharat, in our first meeting itself, he said that okay, there are three topics that I would like to talk about. And I was really excited to see that kind of enthusiasm. So our first one is done, and we have another talk coming up in let me just check quickly. I think that's coming up in on around like 20 of April. That's like
Yeah.
using
Yeah.
open Application SDK for Ferrostar. So again,
Yep.
something that you have given a little bit of information. And then around 15th of June. So I'm also excited for that, modern geospatial formats, because I think that's really important, because so much development is going on with OGC to like create all these different formats and support for those formats. So yeah, excited to talk to you about those as well. So thanks a lot for taking
Me
the
too.
time out, and I hope I'll meet you again very soon, man. Yeah,
Yeah.
thanks a lot.
Likewise.
Thank
Awesome.
you. Thank
Cheers.
you.
Thanks,
Thank
everyone.
you.
Bye.
Bye. Bye.